Hello everyone, welcome back to another video. Today we're going to be continuing with more questions on the Doppler effect. Let's take a look at this one. A learner investigates the relationship between the observed frequency and frequency of the sound waves emitted by a stationary source. So first thing I would do here is that I would write down my quantity on the side, stationary source, so Vs is equal to 0. The learner moves toward the source, so that's important, at constant velocity and records the observed frequency for a given source frequency. This process is repeated for different frequencies of the source, with the learner moving at the same constant speed each time. The graph below shows how the observed frequency changes as the frequency of the sound waves emitted by the source changes. So the first question, write down the type of proportionality that exists between FL and FS as illustrated by this graph. So the type of proportionality shown here is called direct proportionality. In other words, as FS increased, FL also increased. Question 6.4. The gradient of the graph obtained is found to be 1,06. If the speed of sound in air is 340, so they've given us V equals 340. Calculate the magnitude of the velocity at which the learner approaches the source. They want us to calculate VL. We don't know what that is, so they want us to calculate that. Let's go to our formula and see if we can calculate it. So we'll start with the formula. So question 6.4, FL equals V plus minus VL divided by V plus minus VS multiplied by Fs. Now, when the source is moving toward, it's the listener. When the listener is moving toward the source, we can change this equation. So the equation then becomes FL equals V plus VL divided by V minus Vs multiplied by Fs. And I've shown this formula a few times in other videos. I will link them in the top right corner, and how you get them and how you think of, what's the easy way to remember them. Now let's substitute our values in. So FL we don't know, Fs we don't know, but we know the gradient. Remember, gradient is equal to the y-axis divided by the x-axis. In this case, my y-axis is FL, my x-axis is Fs. So if I take this and transpose it, take it to the other side, I'm going to get FL divided by Fs equals V plus VL divided by V minus Vs. Now this represents the gradient, which we know. The gradient was given to us, 1,06 equals 340 plus VL, which is what we want to calculate, divided by 340 minus 0. Remember, they told us that the source is stationary. And now we can solve for VL. VL is then equal to 20,4 meters per second. Okay, let's move on. The investigation is now repeated with the learner moving at a higher constant velocity toward the sound source. Copy the graph, label it A, On the same set of axes, sketch the graph that will be obtained when the learner is moving at a higher velocity, labeled as B. Okay? Let's just use the one that's here. So we label this A. And now we just need to consider or think about how would the gradient be affected for this new graph. So let's go back to our original equation. Our equation before we substituted was this. So this is what we need to use here. So FL over Fs was equal to V plus VL divided by V. Now, if the learner is moving at a higher velocity, this is increasing. If that increases, that's going to have a direct effect on my numerator on this side. My FL will increase. If my FL increases, it means that my gradient will increase. So the graph for B will look like this. Okay, and that's it. If you found this useful, please leave a like, share, subscribe. If there's something specific you want to ask or a specific question you'd like me to do, please let me know in the comment section below. Until the next one,